Welcome back. So let's do a few more. All right, so we want to find the derivative of our cos of negative 7x. All right, so we need to take the derivative of the inside. So derivative of the negative 7x would be negative 7. All right, so this would be dy dx equals, so we have negative 7, right, because the derivative for our cos is negative, divided by the square root of 1 minus negative 7x all squared. You move that up just a tad. Oops, no. Now I'm moving everything up a tad. All right, so we can simplify that. Dy dx equals, so we have now 7 over the square root of 1 minus 49x squared. And there we go. Now we have the derivative. Let's find the derivative of arc cosecant of x to the 7th. All right, so we need to take the derivative of the x to the 7th, which is 7x to the 6th. Our cosecant is also negative, so dy dx equals negative 7x to the 6th. Divide, I love those lines. I think I just, I think I can deal with everything but that line. There we go. Divided by the absolute value of x to the 7th times the square root of x to the 7th squared minus 1, right? And so that's dy dx equals 7x to the 6th divided by the absolute value of x to the 7th times the square root of x to the 14th minus 1. And we're done. Right, let's find the next one. So I think that says 4x to the 4th. Yeah. Again, that chain. All right, so the derivative of 4x to the 4th is 16x cubed. All right, so we've got a bunch of negatives here. Our cotangent is also negative. Let's go back to 14. Here, I got my negative in there, but seem to drop it for the ending. I'm going to have to check every one and make sure I put a negative wherever negative belongs. All right, dy dx equals negative 16x cubed divided by 1 plus 4x to the 4th all squared. So that would be dy dx equals negative 16x cubed divided by 1 plus 16x to the 8th. There we go. I have to say the arctangent, arcotangent, to me those just seem the easiest. All right, so now let's do 17 and 18, and then we'll come back to the antiderivative. All right, so we have to take let's rewrite that first. So we have to take the derivative of the inside, so that's x to the 1/2. That derivative, so I'll just write equals, is 1/2 x to the negative 1/2. All right, so again, we're going to have a complex fraction. We'll have to do a little simplifying. And we may as well just simplify that part now. So it's going to be 1 divided by 2 square roots of x. That's going to be easier to simplify than having that negative exponent. All right, so let's take the derivative. So we have dy dx equals 1 over 2 square roots of x divided by 1 plus the square root of x squared. And notice we now have a complex fraction. So we're going to have to multiply every term. Now here we have 3 terms because it's not a product. So we're going to have to multiply every term by 2 square roots of x. You get a 2 square roots of x. You get a 2 square roots of x. You get a 2 square roots of x. Everybody gets a 2 square roots of x. So we have dy dx equals, right? So now that 2 square roots of x will cancel in the numerator. And so that one cancels. So now we just have 1 in the numerator. In the denominator, we have 2 square roots of x, because 1 times 2 square roots of x, well, of course, it's 2 square roots of x. And then plus, that square and square root is going to cancel, so that's just going to be x. So now we're going to have 2x square root of x. All right, and there we go. So now if we were taking the antiderivative of this one, we would find that a little bit tricky, right? We might not even be able to figure it out because it's kind of disguised when we simplified it. So it's a good thing I didn't ask you to find the antiderivative of that one. All right, so let's try the next one. All right, so we want to take the derivative of 5x times arc sine of 2x squared. Ooh, we have a product rule. All right, so u is 5x. The derivative, that's a du there, is 5. And then here we need to take v is, the v here is arc sine of 2x squared. Now don't forget, we need to take the derivative of the inside, the 2x squared, which of course is 4x. So the derivative of arc sine of 2x squared, dv, is going to be 4x divided by the square root of 1 minus 2x squared. Right, and let's simplify that. I hope we have enough space. That's going to be 4x divided by the square root of 1 minus 4x to the 4th. Okay. All right, so let's find our derivative. So dy dx equals the first 5x times the derivative of the second, so times 4x over the square root of 1 minus 4x to the 4th, plus the second times the derivative of the first. So that would be plus 5 arc sine of 2x squared. And we should really simplify that. All right, and there's just, I'm going to encroach a little on the other one's space. So I can just go right across. Dy dx equals, the one thing we could do is multiply that 5x times the 4x. So that would be 20x squared over the square root of 1 minus 4x to the 4th plus 5 arc sine of 2x squared. There we go. There's our derivative. Right? And now let's go back to the last one here, finding the antiderivative of negative 8x over the square root of 1 minus 16x to the 4th. This one looks a lot like most of the other ones we've done, huh? Where we had a square root of 1 minus something squared. But this time it's negative. Well, which one of those is negative? That's arc cos. Right? So arc sine and arc cos look an awful lot alike. They're the exact same formula, except for the sign. So let's figure out the square root of 16x to the 4th. That would be 4x squared. And if we take the derivative of 4x squared, that's 8x. So that's what f prime of x, that's what the inside part must have been, right? So this is our inside part right here. And this is the formula for arc cos. There's a negative there, I just can't see it. Yeah. All right, so this is going to be f of x. Equals arc cos of 4x squared. And that's it. All right, so in the next podcast, we're going to do a little bit more with finding derivatives. We'll do a little bit more challenging one, and we'll write a couple equations. I just have a few more left, though, for this topic. Thanks for watching. Bye for now.